I'm a senior solutions architect at Elastic, and I just wanted to talk to you guys today about monitoring your applications. We've heard a lot from different folks today, and I'm going to turn the video off so it doesn't distract too much. As we've heard from a lot of folks today, it can become pretty complex and be all over the place as far as how many components of an application, how many applications are running. We just heard from Angel, things can be automated, so the deployments can be huge. And I just wanted to kind of go through and first of all introduce what Elastic is. If you guys have ever used Uber, right? Elastic is the engine that's behind Uber. We're talking about a pretty massive scale, millions of users across hundreds of cities and dozens of countries. Retrieval of that data for an Uber customer is critical, right? You need to be able to do it really quickly. And at the end of the day, Elasticsearch was a great choice for Uber because we offer full text search, geospatial queries, schema flexibility, easy to assemble data pipeline. And Uber also uses Elastic for log analysis. If you wanted to read about that, you can look on the Elastic website and you can look under customer use cases. If you're searching for a restaurant on Yelp, if you're looking for a 5-star taco place that's open at midnight that accepts credit cards, Elastic is the technology behind that search. And it remains a fundamental way that Yelp scales across all businesses where fast and relevant results are integral. And just to spread out a little bit further, the search experience on Tinder, if you're looking for love, or groceries on Instacart, or visual assets on Adobe, those are all powered by Elastic. So many of your everyday experiences, Elastic is behind there, whether you realize it or not. And Elastic is great at search, and it goes beyond just a search box, right? So if you think about Barclays, they're looking for hunting and investigating threats with Elastic. That's a search use case. At Sprint, detecting and resolving operations issues using logs and metrics is a search use case. And also analyzing telemetry data from the Mars rover like NASA does. That is search as well. The list goes on. And today we're talking about, modernization of applications and the many trends and evolving technologies. I know Prashanto at Trilio and Angel just now were talking about this. Virtualization, containers, cloud native, orchestration, and Kubernetes. The hardware and software trends that these are a part of have changed the way software is developed as well, right? Software development wouldn't have happened quite the same way without those hardware and software changes there on the infrastructure side. So monolithic applications are moving towards tiered applications and service-oriented architecture. Some of those have, many things have already moved that direction, and of course, to microservices. And the trends are accelerated by methodologies like CI and CD. And of course, we have serverless, like we heard from Mickey earlier at Checkpoint. That's altogether even different, right? It's ephemeral, they're spun up and torn down, and they may be gone before you even know it. So that adds even more complexity to monitoring. So if we look at kind of an abstracted view of a deployment environment, it could be spread across many different types of technologies. We've got your infrastructure, the quote unquote hardware that things run on. This can be, on-prem, in the cloud, or hybrid. A lot of folks I speak to these days, when they say on-prem, they actually mean inside of their GCP or AWS or Azure environment, right? They're actually talking about VMs as on-prem. And then you have orchestration layers, the hypervisor, the deployment tools, maybe Kubernetes, of course, and that the cloud provider may actually host these services as well. So you've got the things that your applications actually run in. They may be deployed in a VM, they may be deployed in a container or pod, or maybe even on bare metal, right? We see that still for some applications today. And most of them most entire application stacks are a mixture of these, right? So invariably, you also rely on external services, right? Like databases and middleware. And then don't forget the application experience itself for your end users. You need to understand what's going on. And to make matters worse, when you're managing all of this, the observability stack is very likely across many silos. As we heard earlier from Greg, at VMware, many teams are involved in your applications at your business. There's business teams, there's different development teams, and that goes all the way through to monitoring and observability. With the status quo today, your data for monitoring is possibly sitting in many different silos, each team with their own tool. The developers may have some sort of APM tool, your IT operations may have some metrics tools, and your systems administrators may have some log tools. They're all spread out, and not to mention the business teams, which are monitoring their own metrics. So the search for a single pane of glass, it's not new. This is something that's been going on for a while that people are looking for. So what Elastic offers here, our approach to observability is to bring all this data together into a unified platform. By unifying these tools, you gain that single pane of glass across your metrics, logs, and APM data. And you also are able to take full advantage of features like machine learning or alerting, so that when you detect a problem or an anomaly, you can notify folks. Being able to switch between the different data sets can cause time loss whenever you're trying to resolve an issue. And of course, with Kubernetes, this is kind of the pinnacle of all of those different challenges put together, right? You have complexity in layers. You know, if you have a self-managed Kubernetes cluster, you have several additional layers. If you're taking advantage of something like we just heard about GKE, maybe some of those layers are managed for you. But all in all, you have the cluster itself, the individual nodes, the applications, and those are running in pods distributed across the nodes and containers. And then, of course, the application itself, you need to have APM-related information coming in, the trace data. And with everything all in one place, now you can start to find value in your data. So if we just stop for a second, why is Elastic a great solution for this? Remember I said it's great for search. I mentioned several search customers, but think about all the key things that you want to do for observability, right? Discovery, filtering and correlation, anomaly detection across your data sets, alerting, if you want to build a dashboard and pull those different views of data together into a single pane of glass, or even just run a report. What is the common thing with all these, right? When you're trying to perform root cause analysis, right? You're trying to find a needle in a haystack sometimes, or just understand that there is a massive haystack there and determine what needles are. You need to pull them together in order to be able to do that. So all of these are a form of search. Being able to get relevant results really fast at scale is where Elastic comes in. Besides being able to provide you the search capabilities at scale and really fast, Elastic ties this together, in particular with our observability and security solutions, with the Elastic Common Schema. You may hear us refer to it as ECS. And the benefit is we're allowing you to correlate the data from all your different data sources. If you think about just a log file as an example, or metrics coming in from different systems, the actual host name may be in one of 10 different variations of that field, right? You may have a source_IP, source.host, or host.hostname, host.name. If you've ever sorted through logs, you've probably seen a lot of different varieties of that. And what Elastic Common Schema does, and with our pre-built integrations that are out of the box, we actually help normalize this for you. And you can look for host in one field, host.hostname. So when you're building your visualizations, your dashboards, and you're doing correlations, it's all normalized. So if we talk specifically about Kubernetes, what we can do is deploy MetricBeat, which collects the metrics from your infrastructure, and FileBeat, which would collect the logs. And in a Kubernetes environment, this is deployed as a daemon set. We add additional Kubernetes metadata, so you know which node it's running, which pod the actual application is running in. And as you heard from Vijay earlier, these clusters can be massive. So deploying that across all your hosts in your environment could be a pain. we do that again through daemon set, so it's automatic. And like I mentioned earlier, there's pre-built integration. So this example here, FileBeat, you just simply enable the Kubernetes integration, and it starts to collect cluster level logging, service logs. This has got auto discovery feature. So if you bring in a new pod or part of your application, will automatically discover that, so you won't miss that. And then of course the application logs, the container logs within those. And once you have that Kubernetes metadata, and for the technical folks in the audience, some of the fields that you can see here, you're going to be able to pivot straight from an application trace to a host infrastructure metric, maybe CPU memory, to a Kubernetes pod, to a Kubernetes worker node, all of these different aspects. As if you want to troubleshoot, you need to be able to pivot through it and be able to see what's going on. Metricbeat also has that auto discover capability, so when you're looking through those. And with these integrations, there's pre-built dashboards for metric sets that are specific to technologies. We're talking about Kubernetes today, but if you have a Docker only environment, or if you have Apache web servers, we have tons of different integrations pre-built, and those dashboards are specific to those technologies. You can see things that are relevant in terms that are relevant for that technology. And one last thing before I kind of show you this real time, we don't have to just use the Elastic Beats to collect the information. If you already have some telemetry collection out there, open telemetry, or something like Prometheus that came along with your Kubernetes distribution, you can actually go out there and integrate with those as well to pull data in. And then one last thing, you can do agent data collection. So when your code is deployed, we have APM agents that you can deploy with your code. We support the modern programming languages, and that will allow you to collect telemetry. So what I wanted to do is just shift over in my last couple of minutes here and show you, we have a sample environment here that we're monitoring. It's a microservices, multi-tiered architecture. It has some out-of-the-box components as well as homegrown components, a variety of programming languages deployed in Kubernetes in a Google Cloud platform with FileBeat, Metricbeat, and APM collecting information. And while dashboards are super interesting, where we're pulling in data in that single pane of glass, people aren't necessarily going to sit here and watch that, but it is powerful to be able to see my APM metrics, logs, data all together, even business metrics like number of products shipped and the total currency of those sales, number of ads served, user experience, all this is together on top of Elastic. So if you wanted to go in and search for a particular data set or even click on a visualization, you can immediately filter that data as well. Like I was saying, people don't necessarily want to sit and watch a dashboard or even begin their experience here. So what you may do is set up notifications. So in this quick demo experience here, we're going to launch from Slack, a Slack notification, into the Elastic Service Map. And again, this is tooled with the APM agent code, which allows distributed tracing. So I can see the dependencies between the modules. And I can also see that there was an anomaly detection. So we have machine learning running against a set of metrics here in the data set, and I can drill into the service. So if you look at the high level view of the service, you can see the transaction latency. Because this agent code was deployed with the actual application, you can see when new versions went out. You can see the errors as well. And if I drill into the actual main trace here for the advert service, I can see the latency as that one is. For this one particular call, I can see the distribution. So you can see some of these outlying traces took really long. This one's taken 2 seconds. And then I can go in and see the trace information, so you can start to understand what are the long poles in my tent to try to figure out what's going on. What I really wanted to show you though is with this data all in one platform, you can switch, you can pivot to other sets of data. So we're looking at APM. You can also pivot to metric data or log data. So if I first switch over to the metric data, because I'm in APM and it has the metadata enabled, I switch to the Kubernetes pod, and you can see the CPU, the load, and the memory usage specific to that pod. If I wanted to, I could also zoom out and look at all my Kubernetes pods. And maybe I wanted to see those grouped by node and see how that's distributed out. So if I see that I have quite a few of these with high CPU on a single node, maybe I need to go in and reconsider my distribution policy. Also, if I go back now to my trace, let's say I wanted to further troubleshoot this problem where there's some outlying problems here, I could also investigate the logs. So I pivoted to metric data, which is potentially a different tooling environment. Now I'm going to pivot to log data. And again, because I have the in-context metadata, I pivoted over to log files, which if you've ever messed around with log files, especially in Kubernetes, they could be all over the place. And because it's pulled into Elastic in a single platform that gives you quick relevant results quickly, you can also search for things. So I can search for errors like potentially like heap memory. And I'm also pulling in the metric information for other components as well. This is a Java service. I can see the JVM specific information, as you can see here. So this particular problem in the demo, if I would have gone through all the steps, you can see there's a memory leak that's occurring. And lastly, I just wanted to say, hey, if you guys wanted to try this out, if you go to elastic.co, there's a try it for free link, and we give you 2 weeks free cloud access, or you can download the code and you can get 30 days of our fully licensed capabilities straight from the website. So based on this demo, I just wanted to summarize. You can see that all the data across your application deployment is easily and quickly accessible, so you can find issues before your customers are calling you to say there's issues, and you can shrink your mean time to repair.